Chapter 5, Section 3 is our partial fractions. And what we're going to do with those is decompose them. So partial fraction decomposition. If you are given a function, calculus reveals its rate of change. At any frozen instant. This section will focus on an algebraic technique used in calculus to find a function if its rate of change is known. Systems of linear equations can be used to reverse the process of adding and subtracting rational expressions. So this first example, which isn't really an example, is just a little reminder of what we end up with when we subtract two fractions, such as 3 over x minus 4 and 2 over x plus 2. If we recall, we have to get a common denominator. And the common denominator is these two binomials, x minus 4 and x plus 2. Now I'm taking a little bit of a shortcut. So I don't have as much writing to do. This is my 3 over x minus 4, but now it's 3 over x minus 4 times x plus 2, so the x plus 2 has to go up. And in a similar fashion, I have to put the x minus 4 up over here. We then found that we had to distribute to remove grouping symbols so that we can combine like terms. Denominator stays the same. So we get 3x plus 6. Subtract 2x, add 8. Combining like terms, 3x subtract 2x is 1x. 6 and 8 is 14. And that's prime. We can't factor anything out of there. And this is our final answer. Now what we're going to do in this section is take an expression such as this and break it down into this. Now, in order to reverse this process, we must show that x plus 14 divided by quantity x minus 4 times quantity x plus 2 is equal to this. Or we could put a plus sign and move the negative in with the 2. Each of the two fractions on the right is called a partial fraction. So these two, or these two, called a partial fraction. Because it is a combination of these two together which produce this. The sum of these fractions is called the partial fraction decomposition. Of the rational expression on the left-hand side. So we're going to investigate how do we know which two fractions were added together to get the original problem. Partial fraction decompositions can be written for rational expressions of the form p of x divided by q of x, where p and q have no common factors. And we saw that when we saw that x plus 14 could not be factored in order to divide out a factor in the denominator. So they have no common factors. And the highest power in the numerator is less than the highest power in the denominator. So that's something you're going to want to remember as well. So if I look at this, which is p of x, largest power is 2. And if I were to multiply this out, q of x, largest power is 3 after we multiply it out. And when we FOIL here, we'd get an x squared, and then multiply that x squared with that x, we'd get a power of 3. Here in the numerator, p of x power, or we could say degree, is 3. Now when we would square this, x squared plus 1, right, quantity squared, you get an x to the power of 4. So q of x degree is 4 after you square it out. All right, let's do some actual examples after we talk about the steps of what you do. So this process, not difficult, but a little bit long. And once you get the hang of doing these, they actually go pretty quickly. But there are 4 cases, and you'll have to be able to identify the 4 cases. All right, so the steps in partial fraction decomposition. The partial fraction decomposition of a rational expression depends on the factors of the denominator. So if the denominator is not factored, then you must factor it. Okay, so write that in your notes. If it's not factored, factor it. There are 4 cases involving different types of factors in the denominator. So you have to know how to do each case and how to recognize the case. I believe in the homework, part of it asks you just to set up the scenario, not necessarily actually do the partial fraction decomposition, so make sure you're reading the directions so you're not spending a lot of time. Steps in partial fraction decomposition. Number 1, you got to set it up. Set up the partial fraction decomposition with the unknown constants. We're going to use capital letters A, B, C, etc. in the numerator of the decomposition. We're going to multiply both sides of the resulting equation by the least common denominator. We must simplify the right-hand side of the equation. We will then write both sides in descending powers. And equate, which means set equal to each other, coefficients of like powers of x, and equate constant terms. Solve the resulting linear system for A, B, and C, etc. Now, once we're done solving, it's not enough. We have to take the A, the B, and the C and substitute. The values of A, B, and C into the equation in step 1. And write the partial fraction decomposition. All right, you have to be able to recognize the 4 cases. Case 1. The partial fraction decomposition of a rational expression with distinct linear factors. Maybe I should highlight that too. Okay, so distinct, different from one another. I look at these two, they are linear. X minus 3, x plus 4. They are different, distinct linear factors in the denominator. We will have distinct quadratic factors in the denominator. These are linear. Find the partial fraction decomposition of this expression. So we're going to take 5x minus 1 over the 2 binomials. And we're going to say, well, something came from the addition of 2 fractions where one of the denominators was x minus 3 and the other denominator was x plus 4. We don't know what was up top, but because this power is 1, this has to be a constant. So we use A, and here we use B. We need to find A and B. All right, well, how do we do that? I'll have to write tinier because I'm going to run out of room. Okay, so I'm going to recopy this 5x minus 1 over x minus 3, times x plus 4, silly me, equals, now, if you're asked to set up the case, that would be just this. If you are asked to find the partial fraction decomposition, then you're going to move on to this next step. All right, so I'm going to save some space here, probably about the width of 2 fingers. And I'm going to copy what I have above. So would I write this twice if I'm finding the actual partial fraction decomposition? No. This is how you set up this case. And for illustrative purposes, now I'm setting up the case again so we can actually do what it says in the steps. So it says set it up. Okay, we did. Multiply both sides of the resulting equation by the least common denominator. Well, the least common denominator is the product of those 2 items. So I'm going to do that on the left. Remember, this is over 1. I'm going to group that. And do the same thing on this side. Okay, these are going to divide that out. And so I'm left with 5x minus 1 over on the left side. And what do I have here? When I distribute this product to this first fraction, the x minus 3's are going to divide out. I'm left with a times quantity x plus 4. Plus, when I multiply this product with this fraction, the x plus 4's divide out, and I'm left with b times the quantity x minus 3. The next step is to distribute on the right side, because it says simplify the right-hand side of the equation. So this is ax plus 4a plus bx minus 3b. Now I'm going to rearrange this so that my like terms are together. So I'm going to do ax plus bx. Now I don't recommend that you try to take too many shortcuts with this, because if you do, you're going to get mixed up. All right, these two terms have an x in common. I'm going to factor that out. And put it in the front. Well, probably should put it in the back. Plus, now this is my constant, right? Because whatever a and b are, 4 times a and 3 times b, and when I subtract them, it's going to be one single number. And so I'm going to group that as one single number. All right, that's all I could do with that right now. Now number 4 says write both sides in descending power. So we did the x first and then my constant. And we're going to equate coefficients of like powers of x. Here's 5x minus 1. Here is a plus b times x plus 4a minus 3b. Well, guess what? If the left side and the right side of the equation are equal, then a plus b must equal 5, right? Okay, if I cover that up, that's got to be a 5x if these are equal. And 4a minus 3b must equal negative 1. Okay, so a plus b has to equal 5, and 4a minus 3b has to equal negative 1. This is going to produce a system for us to solve. All right, let's set up the system. A plus b equals 5. And 4a minus 3b is negative 1. Now, I think it's easier to use elimination. I'm going to get rid of the a. So the top equation, after I multiply by negative 4 to make it the opposite of 4a, is negative 4a, subtract 4b, equals negative 20. Copy equation 2 down. 4a minus 3b is negative 1. I have a pair of opposites. Now I'm going to add. This is negative 7b is negative 21. B is 3. A plus B is 5. B is 3. So A is 2. And so my final answer partial fraction decomposition. Now, if I said A was 2, then I have to have a 2 here. So it's 2 over x minus 3 plus 3 over x plus 4. Okay, so not too terribly difficult. You have to know how to get the LCD. You have to know which case it is. And the rest is just simply multiplying by the LCD, distributing, combining like terms in order of descending powers, equating the coefficients and the constant, writing up a system, and solving the system. So if you have any questions on that, please ask. I'm going to move on now to case number 2. Case number 2. It's not necessary to memorize them as case 1, 2, 3, or 4. You just have to be able to work with them. The partial fraction decomposition of a rational expression with, again, linear factors in the denominator, some which are repeated. So this one would be called a linear repeated. Notice we have a squaring on the outside of this quantity. Now, to set up this case, you have to be careful because we do need 3 fractions. It's not just 2 fractions here, right? We need 1 for the x, 1 for the first time x minus 1 appears, and then 1 for the squaring. So the setup, x plus 2 over x times x minus 1 quantity squared, we need 3 fractions. 1 for the x, 1 for the first x minus 1, and then 1 for the quantity squared. You must write this as a square, right? Because if we were building our least common denominator, we would need this. That's already in there, and then we would need that. Okay, so this must have happened. Okay, so just remember, you need it the first time, and then you need it the squared time. This is linear, so up top goes an A. This is linear, up top goes a B. This, yeah, sure, if we would multiply this out, it would be quadratic. But remember, these have to be in factored form. This is a repeated linear factor, so up top goes a C. And that's how you would set up case 2 with linear repeated factors in the denominator. Now, for my actual work, remember this was just the setup. I'm going to write the setup again. I'm going to leave some space and I'm going to multiply through by the least common denominator, which is what's in the denominator of this first fraction. Group this, those fractions, those partial fractions on the right. That's going to divide that out, leaving me with x plus 2. When I distribute, this becomes a times quantity x minus 1 squared. Multiplying this least common denominator with the middle fraction, it's going to be plus b times x times one of these x minus 1s. Notice when I distribute the third fraction, I'm going to have cx. Okay, so that's what's going to happen on the right side when I start simplifying it. We have to multiply this out. I have to first start with squaring the binomial x squared minus 2x plus 1, bx squared minus bx, plus cx. Distribute the a, ax squared minus 2ax plus a plus bx squared minus bx plus cx. All right, I've got some quadratics. So you might write a plus b times x squared. Okay, cross them out lightly if you want to so you know you got them. My linear terms, here's an x term, there's an x term, there's an x term. So this is going to be plus negative 2a. Don't forget, there's going to be an x on the end. Minus b, I'm factoring out the x, plus c times x. Okay, minus 2a, minus b plus c. They all have x's. And my constant on the end is plus a. Now, at this step, I realized I didn't write my x plus 2's because I was just working on the right side. I have a quadratic term here, and I don't have a quadratic one here. So I need to insert with a 0 coefficient. You see, because I really technically have a trinomial on the right side. Now I'm going to equate by coefficients. So a plus b times x squared must be equal to 0 times x squared. So a plus b equals 0. All of this, negative 2a minus b plus c, has to equal 1. And a is 2. So I'm going to write the system, and I encourage you to write the system as well. A plus b equals 0. Negative 2a minus b plus c equals 1. And a is 2. Remember, I have to find a, b, and c, so I can substitute back up here in the top to write the partial fraction decomposition. Right here, into these, a, b, and c. Well, a plus b equals 0, and a is 2. So I'm just going to circle a is 2. A plus b equals 0. Well, 2 plus b is 0. That means b is negative 2. Now I know what a and b are, I can find c. So this system isn't too terrible to solve. We don't have much to do with it other than substitution. Negative 2, I know what a is, it's 2, minus b is negative 2, plus c is 1. Here we have negative 4 plus 2 plus c is 1. Negative 4 plus 2 is negative 2, and when I add negative 2 with 1, actually I'm going to take the negative 2 over by addition. I'm going to get c is 3. right? Negative 2, when I add 2 to both sides, I get C, and over here I get 3. So my final answer, I'm ready to set up and write my final answer for the partial fraction decomposition. And say thus, x plus 2 over x times x minus 1 quantity squared is 2 over x plus negative 2 over x minus 1 plus 3 over x minus 1 quantity squared. Okay, so this technically here is my answer. Now you could, if you want to, you could reverse the process, build the common denominator, put your intruders up, multiply everything out, combine like terms, and you will end up with this. Okay, so if you have any questions on the process, please let me know. I know this video is long, but I'm only giving you this as an assignment for the day and to take the notes. So let's take a look at case number 3. All right, so case 3, partial fraction decomposition of a rational expression with prime, so cannot be factored anymore, non-repeated quadratic factors in the denominator. Non-repeated quadratic. So I look at this. Yes, this one's linear, but this is quadratic, so this falls under the category of a quadratic case. Partial fraction decomposition. All right, so what am I going to do? I'm going to set up the case. So 8x squared plus 12x minus 20 over x plus 3, x squared plus x plus 2. I need 2 fractions. I have 2 distinct factors. The first one is linear. Second one is quadratic. Since this is linear, up top is constant. That's just A. Since this is quadratic, this is going to be 1 degree less. 1 degree less. So I need a BX, right? That's quadratic. I need linear. But I also need constant plus C. Okay, so it's important that you know how to set up the partial fraction decomposition. Now, that's the setup. I'm going to write it again. And I chose to write it again because I need to leave some space for my least common denominator. Okay, and the least common denominator is what's in the denominator here. You have to do that on both sides. The left side, the whole denominator is going to get divided out. Distribute. I'm going to have A times the trinomial plus, the trinomial is going to divide out. I have bx plus c multiplied with x plus 3. I have to clean up the right side. Distribute. Ax squared plus ax plus 2a plus FOIL bx squared plus 3bx plus cx plus 3c. Rearrange and factor out any variables. I've got two quadratic terms. That's going to be an a plus b times x squared. Linears. I've got three of them. This one, and this one. So I've got a plus 3b plus c times x. Constants, 2a plus 3c. Please group that constant so you don't get mixed up. All right, I've got a trinomial, and that's a trinomial, so that's good. All right, now I'm ready to equate my coefficients and my constant. So a plus b must equal 8. A plus 3b plus c equals 12. And 2a plus 3c equals negative 20. You have to take the sign with it, okay? It's negative. So I'm going to write my system. A plus b equals 8. A plus 3b plus c is 12. 2a plus 3c is negative 20. Now, this system is a little bit longer to solve because we don't know what a, b, and c are to be able to solve, substitute into one of these smaller models. This got an a and a b, this has an a and a c, so that's not going to work. So I'm going to put equations 1 and 2 together and get rid of a. A plus b equals 8. A plus 3b plus c is 12. Now I don't have opposites, but if I multiply this by negative 1, I will. So I get negative a minus b equals negative 8. A plus 3b plus c is 12. Here's my opposites. Negative b plus 3b is 2b plus c equals 4. I'm now going to put equations 2 and 3 together. So when I do that, a plus 3b plus c is 12. 2a plus 3c is negative 20. I'm going to eliminate a again, multiply top equation by negative 2. Negative 2a minus 6b minus 2c is negative 24. All right, quick pause for the announcements there. Okay, so again, I knew I could get a pair of opposites with a by multiplying by negative 2. This equation is not going to change, so I got 2a plus 3c equals negative 20. Now, remember, I put these two equations together and got rid of a, so then I put the second two equations together and got rid of a again, so that I would have two equations with just b and c. These are opposites. Now I'm ready to add. Negative 6b plus 0, negative 6b, negative 2c plus 3c is 1c equals negative 44. Okay, now I need to put these two together. 2b plus c is 4. Negative 6b plus c is negative 44. I don't have opposites. I'm going to choose to eliminate the c. I'm going to multiply equation 2 by negative 1. Equation 1 did not get affected. Equation 2 becomes positive 6b minus c equals 44. Here's my opposites. Now I can add 6 and 2 is 8. 8b is 48, and 8 divides 48 6 times. So b is 6. A plus b is 8. If b is 6, then a is 2. And now I can find c by substituting into, I'm going to go here, 2a plus 3c is negative 20. 2a is 2. All right, this is 4. I'm going to subtract it. So 3c equals negative 24. So c is negative 8. All right, I've got my a, b, and c. So I'm ready to write my partial fraction decomposition. Let's say thus 8x squared plus 12x minus 20 divided by x plus 3 times this trinomial equals, my a is 2 plus bx plus c now in the top. B is 6, so that's 6x plus c. C is negative 8, so that's 6x minus 8 over the trinomial. Final answer. Okay, so if you have questions about that, please reach out to me. We have one more case, and that, of course, is going to be our repeated quadratic. All right, case number 4, the partial fraction decomposition of a rational expression with prime. Again, it's going to be factored all the way down already. Prime repeated quadratic. Okay, so first we had linear, then we had linear repeated, then we had distinct quadratic, or non-repeated quadratic, and now we have a repeated, because inside the grouping is quadratic and it's repeated. It's 2 times. So how do we set up our case there? 2x cubed plus x plus 3 over x squared plus 1 squared. I need 2 fractions, right? I need it for the first time x squared plus 1 showed up, and I need it for the squared part. All right, it's quadratic, so I need linear up here. Linear is my ax plus b. It's quadratic, so I need a cx plus d. Remember, if this is quadratic, then this has to be linear. You need a linear and a constant. All right, that's how we set up the case. The rest is master manipulation. So I'm going to write the case again. It's part of what's making my video long. Sorry. I'm going to leave some space. My least common denominator is what's in the denominator of the left side. the left side, this gets divided out, so I'm left with 2x cubed. Look, I don't have a square term. You might want to put that in there. Cube, square, linear, constant. When I multiply this with this, only one of these is going to remain. So I get an ax plus b times an x squared plus 1. These will completely divide out, leaving me with cx plus d. I have to FOIL here. Ax cubed plus ax plus bx squared plus b plus cx plus d. I'm going to put in highest to lowest exponent order here. Notice there's only one cube. There's only one quadratic. You could, if you wanted to, you could write it like this. So you see you factored it out. All right, I got my cube, got my quadratic, my linears. I have two of them, a plus c times x. And my constants are b plus d. All right, over here, if you didn't remember or know to put the 0 in there, you would have to put it here because I've got 1, 2, 3, 4 terms. So I need 4 terms over here. I caught it early on. All right. Now I'm ready to do my equating. 2x cubed equals ax cubed, so a must equal 2. B must equal 0. A plus c must equal 1. B plus d equals 3. Now again, I like to write this out so that I'm organized. So a equals 2. B equals 0. A plus c is 1. B plus d is 3. Well, I know what a is, so I can easily find c. So I'm going to substitute 2 plus c equals 1. Therefore, c is negative 1. B is 0. 0 plus d is 3. So d is 3. And we know a is 2 and b is 0. So this system wasn't too cumbersome to solve. Sometimes they are, sometimes they're not. All right, so now we can say thus 2x cubed plus x plus 3 divided by x squared plus 1 quantity squared is equal to, remember we had two fractions, we had an ax plus b. A x plus b, well, b is 0. So I'm not going to write it. It's 0, right? Cx plus d goes over here on top of this fraction. Cx plus d, well, that's a negative x plus 3. Folks, and this is a quantity, so be careful not to pull this out. If you pull this negative out here to subtract, then you have to change the sign of that as well. So keep that in mind. All right, so hopefully you will find these problems not too cumbersome. maybe even a little bit enjoyable to get through them. Okay, if you have any questions on any of them, let me know. You'll have some practice time, and please, please, please check your answers so that I can give you feedback if you are experiencing any trouble. Have a great day.